Good evening students, I am NISHI'S and welcome to NISHI'S Advanced Coaching. Today we will discuss about some concepts of ethers. So let us start. What are ethers? So let me tell you, ethers are the organic compounds which have oxygen attached to an alkyl group. Okay, so how oxygen is attached to an alkyl group? So R bond O. So this is oxygen attached to an alkyl group, and again on the other side there is another alkyl group which is attached. So this alkyl group and the other alkyl group could be same or different. Okay, so first, why it is called as ether? Because it has derived from the name called aether, which is a Latin word and it means to ignite. Okay, so basically ethers at room temperature and pressure ignite or they start combusting. So that is what it is called as ether. So let us see how ethers are classified into different categories. So first is classification of ethers. Ethers are classified into two categories. So number one is called simple or symmetrical ethers. So what are simple or symmetrical ethers? When there are two similar alkyl groups which are attached to both sides of the oxygen, then they are called simple or symmetrical ethers. So what is R here? R here is same alkyl groups. Okay, so now take an example. Here you can observe that here also one single carbon is there, here also single carbon is there. So R represents same alkyl group. So what you get? You get here one carbon, you get here another carbon. So this is called simple or symmetrical ether. Both sides they have symmetry. There is no dissimilarity. There is completely similarity on both the sides of oxygen. So let us talk about the second category. Unsymmetrical ethers. So what are unsymmetrical ethers? When two different alkyl groups are attached on both the sides of oxygen, they form unsymmetrical ethers. So let us check R bond O bond R dash. Okay, so here R and R dash are two different alkyl groups. Are two different alkyl groups. So let us have an example. CH3 bond O bond CH2 bond CH3. So what you can observe here, again you can observe here that here there is another carbon, means only one carbon is there on one side, and here two carbons are there. So here how many? One carbon and here two carbons. Okay, so that forms an unsymmetrical ether, you can say. Okay, so basically ether, symmetrical, unsymmetrical. So symmetrical is both sides having similar alkyl groups, and unsymmetrical means both sides having different alkyl groups. So basically in this you can also have an aryl group which is attached. So what is aryl group? You know that aryl group means it is an aromatic compound or a bond benzene ring. So what you can have? You can have, for example, CH3 bond O bond So this is carbon, one single carbon. This is an aryl group. So you can again you can write it as CH3 bond O bond AR. So AR stands for aryl group. Okay. So this is all about classification of ethers. So basically again we will recapitulate. Classification of ether is of two types. That is, one is simple, that is symmetrical ether, and another is unsymmetrical, which is having both the sides different alkyl groups. Okay. So next is nomenclature of ether. How the nomenclature is done in ether. So let us check. Actually, the nomenclature follows two different methodologies. One is IUPAC naming, another is general naming. Okay. So let's see how ethers are named under IUPAC as well as general. So let us talk about IUPAC naming. So first let us check one symmetrical ether, that is CH3 bond O bond CH3. So always remember that whenever you are doing under IUPAC naming, the lesser number of carbon atoms will be taken as alkoxy, and the more number of carbon is taken as alkane. So always the name of ether in IUPAC naming is alkoxyalkane. Okay. So here you can see that it is symmetrical ether. So what will be the name here? The name here will be methoxymethane. Okay. So another example we can take CH3 bond O bond CH2 bond CH3. So here you can check that the less number of carbon is in the left hand side and the more number of carbon is on the right hand side. So which will be the alkoxy? Always remember that the name is alkoxyalkane. So which will be alkoxy? So this is alkoxy. So you get the name as methoxyethane. Okay. So now let us check another example. So let us take CH3 bond CH2 bond O, and let us take a benzene ring. So how the nomenclature will be? So here you can see the less number of carbon is always attached to oxygen. So here it will be ethoxy. Here it is the benzene ring. So what you will write? Ethoxybenzene. So this gives you the general IUPAC naming of, the IUPAC naming of ether. So let us now talk about the second category of naming, that is general naming. So under general naming, so if you have here methyl group, oxygen and ethyl group. So what do you see? Here there is one carbon, here there is two carbon. Okay. So usually in IUPAC we used to take ethoxy and then methane. But here we have to take alkyl group followed by ether. So again, how to write the alkyl group? So alkyl group will follow alphabetical order. So here you can see how many alkyl groups are there. There is here one alkyl group, here another alkyl group. So what one is methyl, another is ethyl. So after writing the alkyl group, just check which comes alphabetically first. So alphabetically you can see that E comes first. So we will write ethyl, methyl, So alkyl part is over, that is ethyl and methyl. Now ether, you have to attach ether. So the products, this particular compound's name is ethyl methyl ether. Okay, so this is the name of the compound. So this is the general naming. So let us check another nomenclature. So another example. So now again you check that you have both the sides different alkyl groups. Okay, so here there are 2 carbon, here there are 3 carbon. So the 2 alkyl groups, again remember that we have to name it according to alkyl ether. This is the general syntax of writing the name. So alkyl, how many are there? Ethyl is there because 2 carbon are there, and here propyl is there. Propyl. So out of ethyl and propyl, E comes first. So what we will write? Ethyl, propyl, and followed by ether. So this is the name of this particular organic compound. So this is the end of today's session. For different concepts on physics, chemistry and biology, we will come up with new videos. So please subscribe to our YouTube channel, that is NISHI'S Advanced Coaching, and hit the like button. And I wish all of you a very happy Independence Day. Thank you. Jai Hind.